Hi, good morning, Dr. Noora.
Assalamualaikum.
Alaikum salam. Speakers, please, can you join the screen? You can ask to share audio and video and keep muted until your turn.
I think I'm not sure whether because my my headphone is low. Is it because your voice I cannot hear you well. Dr. Lina.
Okay, I will choose.
Uh-huh. Because just now when I listen, I think it's improved now. Can you hear
Okay.
me well? Hello?
Yeah, we
Testing.
can hear you.
Yeah. Right. Okay, good. So right. Wait for 1 minute for me to make announcement.
Yes,
So
sure.
right. So my visual, all right. My visual and my speaker is okay. My mic, okay. You can
Yes,
hear me
okay.
well. Everything
Clear.
okay? Okay,
Yeah,
good.
it's okay. It's okay.
Okay. Because I can hear Lina is a bit far. Hazira okay from my speaker. Yeah, my headphone. Because I'm using my headphone now. Yeah. Hi, hi, hi there. Invited speaker, right? Dr. Yu, yeah.
Yes, yeah.
How are you?
Can you hear me clearly?
Yes, yes. But it's a bit echo, I think.
A bit echo.
A bit echo. If you
Maybe
want to adjust before we start,
this too.
yeah, a bit echo. How about the others? Okay. Sorry, I covered. Yeah, Dr. Siti Aisyah, you want to try with your mic, maybe?
Okay. Is it
Ah,
okay with my
yeah.
mic? Okay.
Yes,
Is
yes.
it
Your
clear?
mic is okay.
Okay.
Yeah, clear.
Okay.
Well,
Thank you,
good.
doctor.
Dr. Nur Shahida?
I'm Ain, representing Dr. Nur Shahida.
Oh, I see. You are Dr. Nur Shahida student, is it?
Yes, I'm PhD
Okay.
student.
Okay, Ain, yeah, your name? Okay. So, can I have your full name? Can you you write at the chat box, please? Just because I'm going to call your name later. But I think Ain, your voice is quite low. I cannot see it. Cannot hear you well. Can you make it louder, please? Can you
Okay.
try?
Is it okay now?
Maybe it's better than before. Yeah. You
Right.
can you speak more?
Speak
Speak more?
more?
Yeah, talk more.
Uh, yeah?
I think okay lah. All right, okay. All right. I think I can just maybe inviting and maybe before we start, yeah? Right. Okay. I can see the speakers, every speakers, invited speakers and also the presenters for today, yeah? So I shall, start briefly. So I've asked everyone with the mic and whether the mic or video is okay. Right. So Assalamualaikum and very good morning to all of you. Ladies and gentlemen, we are about to begin our session, Biomaterials, Polymer session. Please stand by. I would like to seek for your kind cooperation to avoid any virtual disturbance during this broadcast session. If you have any question, the conference resource personnel are ready to attend you at the reception desk. Okay, on behalf of the MIC&C 2021 Organizing Committee, I would like to seek for your kind cooperation to fill up the feedback form as given by the session moderator in the chat box. I think do you provide that? Miss Lina, Dr. Lina?
Yes, doctor, I
Miss
will
Lina.
provide in a moment.
Okay, thank you. Thank you for your kind cooperation and attention. We will start at 3:40 p.m. Okay, which is about I think about 3 minutes more. Okay, 3 minutes more from now. Okay, so we shall start exactly on time. All right. Hopefully, if any one of you, the presenter and also the invited speaker, if you like to, test your mic, your presentation or something, you can feel free to do it now. Maybe we can start with the first presenter, Dr. Siti Aisyah.
Yeah.
You want to try?
Yeah, I want to try because before
You
this
will
I
just
cannot share the windows. So I just can share the entire screen.
Mhm.
So now, okay, I just share the entire screen now.
I got the actually you can share, but you have to open your whatever your slide first before you actually sharing it. You make
Yeah,
sure it's open before you share the windows.
okay, I
For
tried.
example, you okay,
Okay,
do
I
it.
try now by choosing a window.
Mm.
Okay, so this,
This is the
okay,
screen, eh?
yeah, my screen, but the I already opened the PowerPoint, but still, yeah,
Even
cannot be
it's still
seen.
cannot. Okay,
Yeah,
so then you
so
have to share
I
the
see
entire
an
window.
entire window. Okay.
Okay, all right. Okay, I think your voice okay, Dr. Aisha. How
Okay.
about Ain just now?
Can I share the entire window?
Yeah, you can
Okay.
try.
Okay. So you can see my slide now.
Yes, yes.
Okay.
Can you just scroll your slide maybe to the next slide? So it's not.
Okay. I can control the slide. Okay.
Okay.
Okay. I try the laser point first.
Mm.
Oh,
Okay, seems okay.
okay. Seems
Mm.
okay. But I can't.
Mhm.
Okay.
You cannot see us, yeah?
Yeah. Cannot see. Just
Actually, there's a way. There's a way.
okay. I stop
Uh,
sharing now.
there's a way, but okay, it's fine. So it's because it's almost time to start. Maybe you can start, yeah, first. But let me introduce you, okay, before we start. Right, it's already 3:40.
Okay.
Okay, so I'd like to make an announcement first. Okay, ladies and gentlemen, oral presentation will be evaluated for the awards under two categories. The first best session presenter that will receive the certificate for best presenter, and I will announce at the end of the session. The best presenter award that offered prize money from 500 to 1,000 ringgit Malaysia. The trophy and award certificate will be given. This will be announced during the closing ceremony. Okay, I would like to seek for your kind cooperation to mute your mic if you are not presenting and to avoid any kind of virtual disturbance as possible. For those who intend to ask questions to presenter, you can channel your question in the Q&A box. I will read it after every presentation. You can also request to share your audio and visual to ask your question in live mode. Presenters are given 50 minutes for presentation and 5 minutes for Q&A session. Whereas for the invited speakers, you are given 25 minutes for presentation and 5 minutes for Q&A. I will remind the presenter to end the presentation 5 minutes before the presentation ends. So Miss Hazira, could you please ring the bell as an example, please? Yeah, that's the bell. Thank you, Miss Hazira. So I will stop the presentation session when the session has exceeded 5 minutes allowed. Okay, before we start this parallel session, I would appreciate if everyone can turn on the camera for the photo session. Okay?
Okay, on the count of three. 1, 2, 3. Thank you very much.
Okay, thank
You
you.
can reshare now, Siti.
Okay, right. Okay, without further delay, we'll be hearing a presentation from our first presenter, Dr. Siti Aisyah binti Samsudin, with her presentation title Gamma Irradiation induce cross-linking of latex, polystyrene block, polyisoprene polymer blend. Please welcome Dr. Siti Aisyah.
Okay, thank you, Chairperson. Okay, so I'm Aisha from UKM. I would like to share our finding about this title. Actually, this is part of our big project under FRGS. So collaborated together with Dr. Nashaidah. Okay, so here, why we choose this natural rubber, because we have abundance of natural rubber sources in Malaysia. As we can see here, is listed as a
Dr. Aisyah, can you share your slide, please? It's not coming out.
Yeah, I already shared.
Oh,
so
is it?
you cannot see it.
Dr.
Can you
Lina?
share again? No, can you share again?
Can
Because
Can you share again? It doesn't appear here.
How to? Okay, before this we can see it. Now you can see it. Mine. No. Because I already share entire video. Entire screen, right?
Screen. So maybe you need to
just
unshare.
share again.
Unshare back.
Unshare and then coming back.
Okay. Okay.
Yes.
Okay.
Okay, we can see it.
Yes. Okay, let's start from this slide. Okay. Why we choose this natural rubber as our main project? Because the natural rubber in our country, we have abundance of that resource. So as we can see from this statistica, Malaysia is listed as the country that leading the natural rubber producing worldwide in 2019 and 2020. So however, this Thailand and followed by Indonesia has monopolized this market due to the pandemic. We can see here that 2019 of the 2020 production is decreased down. However, actually, if we compare 2018, actually the the value of the percentage of the production for 2019 is increased if compared to 2018. That's why we go further to this study, because it's still relevant to study on. As we know, because the natural rubber itself have the speciality or the special properties, such as its environmental degradable and also renewable homopolymers, because it's natural source if we compare to the synthetic rubber. So and also another the special properties of this natural rubber, that why this natural rubber is highly demand, especially to produce the glove right nowadays. Okay, so because it's high elasticity and also wear resistant of this of the properties. So however, this rubber latex has an advantage, because they have a low thermal stability and also low tensile strength. This is the challenging for us to increase the thermal stability and also tensile strength. And how we can improve this NRL properties by induce the or make it as a polymer blend. Okay, we cooperate this natural rubber with the block copolymer together. The special is after we blend this polymer together with the block copolymer, this polymer blend can have two properties because this is composition of two homopolymers. So as we can, I will discuss a bit later. So we can enhance the degradation performance. This study will show the enhance of degradation performance, and also it's increase the compatibility between the block copolymer and natural rubber. So in this study, we introduced to use the gamma radiation to induce the cross-linking via this via this bonding. Okay, because this natural rubber cis-1,4-isoprene, that has a special this bonding. The speciality of this bonding, we can modify this bonding and do the mechanism either here, or here. Okay, this gamma irradiation will irradiate this polymer and make the polymer change which generate the radical by absorbing this cobalt-60 gamma irradiation. So after absorbing the gamma irradiation at optimum, they will increase the cross-link inside the polymer change, or if they receive excessive energy, they will go the scission or degradation process. Okay, so what the advantage of this gamma irradiation if compared to the commercial or conventional techniques, we propose the green technology because this gamma radiation we will not use the high temperature, and also we avoid of using the cross-linker agent. Okay, so why we focus to the low gamma radiation dose in this study or this project? Because most of the researcher they are focusing on high dose radiation. Most of them use more than 50 kilogram. That is costly. So for this project, we want to induce the cross-linking and also enhance the mechanical and thermal properties by choosing the lower or as low as we can the low gamma radiation dose. Okay, so for this subtopic, we choose 50-50 ratio of the NRL to PSB PIPS, this is block copolymers, because based on our previous research, this 50-50 ratio give the optimum elongation at break if compared to the other ratio. So in this study, I will discuss on the mechanical properties, soiling test to show the percentage of gel content, and thermal analysis, and finally the FTIR to show the bonding occur in this blended polymer. So based in, as we can see from these mechanical properties, it's clearly been seen that the tensile strength, Young modulus, and elongation give the similar trend if we compare between the unirradiated to the irradiated. Okay, after irradiate the sample, the value of the tensile strength and Young modulus has increased up until 12 kilogram here. This is an optimum dose. While its degradation process happen when we irradiate at 12 and 14 and further. So we understand here there is a more propagation of degradation process compared to cross-linking. So as we can see here, the percentage of the tensile strength and Young modulus has increased proportionally to the increased the radiation. And from the elongation at break here, the elongation at break has increased after we irradiate at 4 kilogram, but however suddenly it's decreased down when it start from the 10 kilogram. We understand here they have formed the rigidity formation of the polymer change here. So that's why it's slightly decreased down, but if we compare to unirradiated, it's still flexible. Okay, so we move to the gel content. Okay, because the mechanical properties is highly depend to the degree of cross-linking, so we need to prove the cross-linking inside this polymer blend. That's why we really need to prove by gel content percentage using the swelling test here. So as we can see here from this gel content result, unirradiated sample here obtain 11%, while it's going up to 35% after we irradiate at optimum dose, which is at 12 kilogram. It shows the consistent result if we compare to with the mechanical properties. Okay, as we can discuss about why this the gel content percentage is increased here because it's the same reason the sample has absorbed optimum energy and make the chain inside the polymer can be vibrate and form the free radical to interact with the between the natural rubber and also with natural rubber and block of polymers to obtain or induce the crosslink. That is why we get a high or optimum percentage here. So we want to prove about the thermal stability, as I mentioned before. So for thermal stability or thermal properties of this polymer blend, we have done two kind of the thermal analysis, which are DSC analysis and TGA analysis. So for DSC analysis, it's shown here that TG, glass transition temperature for this polymer blend is increased from minus 61 to minus 60 when we irradiate to optimum dose of gamma irradiation. So as we can understand here, because inside this polymer blend, after irradiation, it's formed obtained the movement of polymer chain is restricted due to the obtain or induce the cross-linking. While when we go to the TGA analysis, that actually has a slightly different of the melting temperature here at 5% of weight percentage loss, weight loss percentage of weight loss, which is slightly after irradiation, the TD or the TM is slightly increased, about 10 degrees C. Okay, when we after we analyze the DTG curve here, actually we can identify based on this DTG, they have two stages of decomposition process that we cannot be seen from the TGA curve. The first stage is belong to NRL decomposition, while the second stage is for PS decomposition. And this TD, that is the degradation temperature, is increased, okay, after we irradiate with optimum dose. It's shown here, the sample after irradiation getting more stable at high thermal, and also after we analyze the data, we found out that there has a remaining PS here that's caused by the retarded pyrolysis process of this polymer blend. So that is why we conclude here they have the energy barrier, okay, and energy shielding happen here. That's why they still have the residue of PS. So this is a functional group and bonding. Is a very important analysis for confirm or make sure either that is it correct, this polymer blend already cross-linked or not. So based on this study, we analyze that in the green circle here is the functional groups from the NRL, while in pink circle is from the PI that consists in the block copolymer. While PS is we label as in the purple circle. So as we can see here, actually, the frequency here is become broader. Okay, we understand from this phenomenon that is the OH group is decreased the density here because the oxygen is dissociated from this natural rubber blended and obtain rich isoprene unit here, okay, for 12 kilograms. While Okay, so for this polymer for this cross-linking mechanism should be proposed in three kind of mechanism, 1, 2, and 3. For our study, we have identified that we our natural rubber latex blended with the polystyrene, polyacetylene polystyrene block copolymer has following the mechanism 1 is because the CH group has obtained here. Okay, if we compare to the others peaks or the wavelength, there's no CH group here. Okay, so secondly, so there has C double bond. Actually, C double bond here not only for the natural rubber, but actually for the benzene ring from the polystyrene of the block copolymers. Okay, that's why the frequency of the C double bond here is strong or extremely strong compared to these both doses. Okay, so if we then another thing that is we compare with the double bond CH wagging is occur here. Okay, so there is no or only a weak vibration or frequency has occurred for this unrelated and 8 kilogram irradiation, but for this 12 kilo irradiation, he's appear as a strong peak. So that's why we understand and we claim that our sample have following this mechanism on obtain or induce the cross-linking. And I forgot to tell you, if you can see here, by we comparing the vibration frequency between these three sample, they has they shown the strong vibration at 12 kilogram because at 12 kilogram it's absorbed, as I can say before, it absorb more energy and it's generate the more radical of C to interact with the SIS. Okay, so for this vibration or peak, we understand that actually this sample is well blended. Okay, if we can compare with the NRL and SSS peak here. Okay, so finally, what I want to show you is the CH. The CH peaks that is only occur in this sample is due to they have a CH vibration or band only belong to this pH, this PS aromatic benzene from the PS. Okay, finally, we are confirmed that actually this block copolymer has do the interaction or linked between this polyisoprene with this CH of natural rubber latex. Okay, so I go to the conclusion. We prove that 12 kilocalorie is an optimal radiation dose, while the cross-linking has obtained at CH bond from the CH14 isoprene and following the mechanism 1. Okay, we thanks to Agency Nuclear Malaysia for gamma radiation facilities, and this project is funded by Ministry of Higher Education, MOE. Thank you.
Thank you, Dr. Siti Aisyah.
Okay.
Right. Okay. Thank you very much for addressing this interesting topic. So, ladies and gentlemen, now we come to Q&A session. Please mention your name before addressing your questions, and I will raise question from the Q&A box. Okay, maybe I start from the Q&A box. Right. All right. So the question to Dr. Siti Aisyah: is there any specific characterization test or tool to ensure that polymers cross-linking by the gamma irradiation?
Okay, actually we have done another analysis by using NMR, but that is for another manuscript that is under review. So by using the NMR, actually we can prove more about the cross-linking or cross-linked obtained between the NRL and block copolymers.
All right.
Okay, but we not present here.
Okay.
Okay.
Thank you. Right. Uh, okay. Now, thank you for the for answering the questions. And now, I forgot actually to mention few things at the beginning of our session just now.
Mm-hmm.
Just to say that we are now in the session Biomaterials and Polymers. And my name is Dr. Norazlawati Muhammad Sare from I'm an associate professor from Chemistry Department Universiti Malaya, and together with me is Dr. Lina, as you can see from the screen, and also Miss Nurul Hazira as a IT personnel. So yeah, so maybe I'm so excited to start from the first presenter just now. Right. Thank you very much. If I can, yeah, there is no question from others. So maybe we can move on to the next speakers, next presenter. Thank you very much, Dr. Sitaisha. Please hold on with us. Right. So for the next speakers, to our second presenters, please welcome Che, just now, Che Nur Ain Muhammad Razali. Okay, right, Che Nur Ain. Right. The presentation title is Mechanical Properties of Polymeric Biomaterials Modified Expanded Polytetrafluoroethylene PE PTFE using gamma irradiation. Okay, please welcome Che Nur Ain. The screen is yours. You can share your screen now. Cik Nur Ain, can you unmute your, yeah, okay, please. Hello? Okay, we
Hello.
can hear you. Okay,
Can everyone see the
yes,
slide?
thank you.
Assalamualaikum and a very good afternoon to everyone. My name is Nur Ain binti Muhammad Azali and I am a PhD student from Science Nuclear UKM. I'm a PhD student supervised by Dr. Nur Shahida binti Muhammad Hizir, and today I would like to share my research topic titled Mechanical Properties of Polymeric Biomaterials of Modified Expanded Polytetrafluoroethylene, or we call it EPTFE, using gamma irradiation. So for introduction, I would like to introduce about what is actually EPTFE. So if you do not know what is EPTFE, I think most of you know about. I think most of you know this material, which is PTFE. So PTFE is actually the expanded version of PTFE, in which PTFE is expanded at high temperature up to 300 degrees Celsius, which make it become a lot of become porous with a lot of pore here. And it is actually consists of a carbon and fluorine bond, which make it very inert and hydrophobic. So EPTFE has been widely used in many kind of application, as well as in medical application. So the advantage of using EPTFE as biomaterial is because it is porous, so it will allow the body tissue to network and grow. And the second one, it is inert, so it does not deform when interact with body tissue and has low propensity to trigger thrombosis. So these are the example of EPTFE used as polymeric biomaterial, which is as suture, surgical meshes, heart valve, facial implant, and also barrier membrane. So, however, this is the the disadvantage of epitaxy because the hydrophobicity reduce its biocompatibility. So that's why in this research I want to modify my epitaxy to reduce the hydrophobicity using gamma radiation induced grafting method. So why I want to use the gamma radiation induced grafting method? Because one, it is easy and clean method, and the second one is it maintains the original bulk properties, which I only alter the extreme hydrophobicity, and the production of radical upon exposure to gamma radiation was used to graft my desired copolymer. So these are actually the process of grafting. This is the original structure of epitaxy, and this is the monomer to be grafted onto epitaxy. So after it is being exposed with gamma radiation, it will form radicals. So these radicals, uh, this radical produced will will form a new polymer that is I mean modified polymer that is crafted with my desired uh, monomers. So instead of using one type of monomer, I'm using two types of monomer, which will increase the effective in reducing its hydrophobicity, and the second one, it will increase surface functionality when two characteristic of dual monomer grafted onto epitaxy, or I call it as smart polymer. So the monomers that I use in this research are all hydrophilic monomers, and the monomers that are widely used in medical applications such as alkylic acid, 2-hydroxyethyl methacrylate, and isopropyl acrylamide, NIPAM, and also N-vinyl caprolactam. So the set of comonomer that I use, which is acrylic acid copolymer with HEMA, or I label as AH, acrylic acid copolymer with NIPAM, I label as AN, and acrylic acid copolymer with NBCl, or I label as AV. This is the symbol. This is the symbol that I will use throughout this presentation. So my presentation will be focused on the physical properties of epitaxy after the modification process, and also the second one is the mechanical properties of epitaxy after the modification process. So for polymeric biomaterials, mechanical properties is one of the important criteria to look into, because the mechanical stress can affect the performance of tissue healing. So this is the example. So the initial properties of epithelium, which is hydrophobic. So when I have these three sets of monomer individually grafted onto the epithelium, so it will become less hydrophobic. So these are the methodology of my research. This for the EPTFE modification, it is an easy process because we only need 1 molar of concentration of copolymer acrylic acid HEMA, or acrylic acid NIPAM, or acrylic acid NVCl, and then we added the more salt because the simultaneous irradiation process will cause homopolymer formation. So for comonomer AH, I will radiate it at 0.5 kilo gray, and for comonomer AN and AV, I irradiate them using 2 kilo gray gamma dose. Why I choose this dose? Because this is the optimum grafting yield that is produced. So for characterization, for the physical properties, we'll measure the grafting yield, and then the percentage of water uptake, and then the contact angle measurement. And the second one is I want to see the morphology of the modified EPTFE using PSM analysis. And the third one is the mechanical testing, which is the Young modulus, ultimate tensile strength, and also elongation at break. Okay, first for the result and discussion, we'll see on the physical properties of the modified epitaxy. So in this picture, you can see that the sample in a dumbbell shape. So this is the epitaxy, the untreated epitaxy, and this is the epitaxy that is irradiated with 2 kg without the presence of comonomer. And this is the sample acrylic acid AH in dry and wet condition. And this is sample AN in dry and wet. And this is sample AV in dry and wet condition. So this is a table for length in dry and wet condition. So this is grafting yield that is measured using which is the initial indicator of the successful of the grafting yield, where we measure the percentage of the weight increase, and also this is the water uptake of the grafted sample, modified sample, of which the sample is immersed in the ionized water for 24 hours, and the increase in mass will be times by 100 and see to get the percentage of water uptake. So as we can see here, the sample, the modified sample for AH, AN, and also AV in dry condition showing a shorten in length, which is about 6%, and for sample AH and AN, and while for sample AV is 3%. This might be due to the percentage of grafting yield. So we can see here the higher grafting yield will show us more shrinking in length. So however, in wet condition, all of the modified sample extend to its original dimension as before modification. Next is the modified sample. Besides the length of the sample, you can see that the color changes for the modified sample, where sample in wet condition show colorless sample, colorless in color compared with the dry one, which show that the modified epitaphy were able to absorb water due to the presence of hydrophilic comonomer grafted onto the surface. So we can conclude here that grafting caused the dimension of the epitaphy to shrink, and also grafting modify the hydrophobic epitaphy become less hydrophobic. Okay, next is the wettability and also the contact angle. Okay, the contact angle analysis also show that the successful of the grafting process of the comonomer that I chose to be grafted onto epitaphy. So as we can see here, the blue color represents the epitaphy, and also epitaphy irradiated at 2 kilogray here. So this sample is a sample that is not grafted with anything, and the purple one is a sample AH, which is grafted with AH. The pink one is sample AN, and also the AV. So we can see it from the wettability and contact angle graph here. All of the modified samples show less contact angle value compared to the unmodified one. So next we go to the morphology of the unmodified sample. So this is the unmodified sample, which consists of nodes and fibrils. So after the modification process, we can see that the node was seen to be larger in all of these three samples, AH, AN, and AV. And the fibril was seen to reduce in length for all samples, which is indicator of successful grafting. So next we go to the mechanical properties of unmodified and modified epitaphy. So the Young modulus is actually the ratio of stress to strain. So we can see that there is a significant difference between the unmodified epitaphy and also with the sample AH and AN in dry condition. So the mechanical tests were the mechanical property were tested in dry and wet condition, because the biomaterial will usually will be exposed to wet condition. So we can see that a sample AH and AN show highest high young modulus, and higher young modulus in modified sample show that the sample becomes stronger, which means that they not easily deform. So for ultimate tensile strength (UTS), the significant difference was observed between a modified sample and also all dry sample. And the highest UTS value is from sample AH with 8.8 and megapascal. Um, the sample EPTFE that is not grafted with any kind of comonomer also show a significant difference with the modified one, which show that the scission of the polymer due to gamma radiation, which resulted to exposure damage in the trunk polymer. And the last one is the elongation at break. So we can see that there was a significant difference between the um, all modified sample with the initial one. And the modified sample show a shorter elongation at break compared with the untreated one. So as for conclusion, the mechanical behavior of EPTV after modification with various comonomer by gamma radiation show changes in the tensile performance. And the changes in mechanical behavior is obvious when the modified EPTV is in dry condition but not in wet condition. And the morphological changes after the modification of EPTV as well as the percentage of grafting yield play a role in the tensile performance obtained. The mechanical data also prove that the gamma irradiation can affect the mechanical performance of the polymeric material without the presence of any monomer. And most studies such as crystallinity, porosity, and also thermal properties are needed for the understanding of mechanical properties of biomaterials. So that's all for me. Thank you.
Thank you very much, Cik Nur Ain. Okay. So now we can invite, we're going to Q&A session. Like, maybe I can have a look to the Q&A box. So the question is, Dr. Siti Aisyah, is there, oh, okay. So representative of Dr. Siti Aisyah, Nur Ain, Cik Nur Ain, is there any specific characterization test or tool to ensure polymers cross-linking by gamma radiation?
That's I think that's question for Dr. Siti Aisyah.
Oh, sorry. Oh, okay. On the
Ah.
top, sorry. I read the wrong one. Okay. Thank you for the presentation, Miss Ain. Can you please elaborate more on relation between grafting yield and length of the modified ePTFE?
Yeah. If you can see that in my slide, the FISEM, the morphology for FISEM analysis, the modified sample show a larger nodes and a shorter length of fibrils. So I think that's why more grafting yield uh, creates more nodes compared to less grafting yield sample. So more nodes and also shorter fibrils creates a shorter length of modified samples.
Okay. Thank you for answering the question, Cik Nur Ain. Okay. Right. Okay. I think for the next, without further ado,
Sorry, Dr. Nora. There's another
yeah.
one question here on the chat
Okay.
box.
Where is it? On the chat box, right? Right. From Dr. Sitaisha, just now may I know what's the difference between ePTFE and ePTFE2 parameter? What's the function of each monomer?
Oh,
Thank you,
actually,
Dr. Sitaisha.
actually, EPTFE2 is EPTFE that is irradiated with particular grade of gamma dose without the presence of monomer. So I just want to see whether what are actually the effect. Is it the gamma ray or is it because of the presence of monomer that will affect the mechanical properties? So from the result, it show that the UTS value for the sample EPTFE2, which is irradiated with gamma irradiation without the presence of monomer, also show changes in medical UTS value, not just because of the comonomer. What is the function of each monomer? Each monomer, they are all hydrophilic monomers. So I chose my desired properties of comonomer because all are hydrophilic, but for example, monomer NIPAM and also NVCl, it is a thermosensitive monomer. So when I combine the thermosensitive monomer with hydrophilic monomer, so I can have one materials EPTFE which have two kind of properties. Which can behave into dual properties of polymer, which I call as smart polymer.
Any other question?
Excuse me, I got one question.
Dr. Malinda. Yes, please.
Okay, Assalamualaikum Nur Shahida.
I'm Dr. Shahida's student.
Okay, oh yeah. I have a question. Can you explain the reason behind the low breaking percentage for your grafting sample as compared to ungrafting?
Low breaking in the mechanical performance?
Yes, correct.
Maybe due to the if you can see the morphology, the nodes and fibrils, the morphology of the modified membrane had already changed. So that's why the nodes prevent the elongation to be longer than it should be. So one of the factor is that the grafting yield also affect, and also the elongation. So that's why when grafting yield increase, the nodes are more than the initial one. So the elongation cannot be more longer than the initial properties.
Okay, thank you for your answer.
Thank you, Dr. Malinda, for the question, and thank you, Cik Nur Ain, for the answering the question and also for the interesting talk. So now we're going to move on to the next to our invited speaker. Right. Okay. So suddenly the one I'm open just now is all right. Let me see. Okay. Okay, now we move on to our invited speaker. Please welcome Dr. Yu Ming Chen with his presentation titled Influences of Nano Biofiller on the Physical, Mechanical and Fire Protection Properties of the Intumescent Coating. Please welcome Dr. Yu.
Okay. Yeah, a very good afternoon to all MICMC 2021 participants. Our chairperson, Associate Professor Dr. Nora Jilawati, organizing committees, ladies and gentlemen. Okay, first of all, I would like to thank the MICMC organizers for inviting me to share my industry collaboration research on this titled Influence of nano-axial biofillers on the physical, mechanical, and fire protection property of the Indonesian coatings. Okay, my research areas mainly focus on fire protection materials and the cool roofing technology system. Okay, so I attach to this Faculty of Engineering and Science, Department of Mechanical and Material Engineering, Utah. So if you can see the first slide on the left of these photos, yeah, you can see 72 people died after this huge fire engulfed in this Grenfell Towers happens on 14 June 2017. So this problems due to the cladding materials, which are non-combustible materials, cause these fires spread very fast. Cause all the occupants or residents here no time for evacuations. So today my research will try focus on all these fire protections, how to stop these fires when exposed to all the heat. So my presentation outlines will be emphasized on these 7 sections. First are problem statements, novelties, introductions, and objectives. For the section 4, I combine the materials, methodologies, and the results and discussions, so that all the audience here can just view the single slides. Then it will be easier and convenient for audience here to see the difference. So next is conclusions. Of course, I will touch on all the applications in my research team milestone. So you can see the problem statement here. So according to this, the World Health Organization, about 322,000 people dead per year due to these fire accidents. So all this happens due to lack of exposures and knowledge about these active and passive fire protections. So besides this, the insulation coatings itself is very expensive. So far, I think in the world, not many industry focusing on this insulation fire protective coatings. Only a few industry or companies. So next, according to this OSK research number, this one is, I think, our Malaysian people. Maybe here you can see about 3.4 million metric tons of egg cells we consume per month in Malaysia. So this is a very huge amount. Actually, we can convert all these waste materials into this very useful and very useful applications to protect our life in the event of fires. So next, the World Bank also conduct all the statistics. The QDA produced the largest amount. You can see here 49.1 metric tons of this carbon dioxide are prohibited in the world. All this lead to the global warming. So actually, our research focus here is try to solve all these problems. So next, the novelty of this project is this the new findings actually come from the usage of all these waste chicken egg cells, nano biofuels, which is an agricultural byproduct. So actually, we try, I think, a few hundred times how to convert all these egg cells from all the egg cells to micron size and nano size. So actually, these findings have been granted. The intellectual property have been granted. So these IP numbers. So of course, besides it, we also focus on hybrid or flame-retardant fillers added into binders and flame-retardant additives to enhance the fire protection performance, physical and mechanical properties of the insulation coatings. So you can see the picture here. Actually, we collect all these waste chicken egg cells from the chicken farm. Here you can see a few metric tons. They just export to the land. So cost, I think the land cannot be used for plantations. This is agriculture byproduct from Stelwan Perak. So next, the introductions are actually what is insulation fire protective coatings. Many people actually not aware about these materials. So maybe I briefly explain. Actually, at ambient temperature, this coating look like ordinary paint or coatings. But when this coating exposed to fires, when the temperatures exceed 200 degrees Celsius, so it will start to expand. It depends on the formulation. Some may expand up to 100 times if you compare with the original thinness. So for my research, normally our target here is only expand out to 20 or 30 times. I think it's the maximum because we consider a lot of features for all these industrial applications. So you can see the right side, it can expand about 20 times for this to prevent all the heat transfer into the substrate, to protect the substrate, to maintain all the integrities. So next, how can a substrate be protected by this insulation fire protective coatings? So actually, the basis of the fire protective coatings come from the mixtures of eco-friendly flame-retardant ingredients. So maybe in the next few slides, I will show what is eco-friendly flame-retardant additive. So we all know that materials can decompose and even burn, right? But do you know that insulation coatings can protect the integrity of a coated substrate between 1 to 3 hours in the event of a real fire? 1 to 3. So it depends on the thinness of the fire coatings we apply. So you can see even we can use our hand to hold it if we apply this intumescent coatings on plywood. But for steel, of course, we still can feel the hot temperatures at the backside of this steel if we use our hand to hold on. So I think here we apply on plywood to see the significant performance. So next, the advantages of using this intumescent coatings in industry. So first, to extend the evacuation time during fire breakout. So this enables safe evacuations, saving PC's life while reducing all the building damage. So besides this, it also can protect the coated substrate in the event of fires. So this intumescent coating do not modify the intrinsic properties of all the coated materials. So it's lightweight and easily coated to the substrate. We can use spray dye, paintbrush to coat on any substrate. So it has a very good decorative effect for maintaining the aesthetic appearance of buildings. So next, the objective to evaluate the effect of nano-SL biofuel on the fire-resistant, water-resistant, freeze-thaw cycle, durabilities, and adhesion strength of intumescent coatings. So for this sharings, I just focus on 5 tests. Instead of, I think we have done about 15 tests. So here I just show 5 tests. So next, to determine the fire protection performance of the intumescent coatings on the coated substrates. So the material used here is, as I mentioned just now, eco-friendly flame retardant additive here is ammonium polyphosphate as acid source, the pentatridol as carbon source, and the melamine as blowing agents. So we need these 3 flame retardant additives to form a team to make sure the coatings by exposed to fire can expand. So in 19th century, most of the researchers they are using non-halogen or they are using halogen based. So this eco-friendly flame retardant additive is non-halogen based. So in Americans and Europe countries, they have already banned all the halogen based materials. So next, we need to incorporate all these flame retardant fuels here. Actually, flame retardant fuels play a very important role in formulating this intumescent coatings to work all the fire protection performance and all the mechanical properties. So the polymer binder here, we can decide whether you want to formulate water-based or solvent-based. So for this project, we using these water-based binders. So this is the specifications of experimental materials. So for these formulations here, we only show 4 coating formulations. So we highlighted these nano-SLs only samples M and O we incorporate with these nano-SLs 2.5 and 4.5. So for all the flame retardant additives, polymer binders, pigments here are the same. We only play around with different weight percentage of flame retardant fillers. So the methodology part and result and discussions. So maybe we can look at these methods how to produce this nano-SL biofuel. So first, if we collect all these waste by egg cells from all these chicken farms. So of course, these egg cells have to be cleaned up thoroughly and the membranes have to be removed. So we try it for 4 hours at 90 degrees Celsius in the ovens to make sure all the egg cells is bacteria free. So next we ground to a powder form using lapping machines. So this one we can get all in micron size, but above maybe 50 microns. But next we have to mill it to nano size. So this is a very simple and new found methods. We just use wet millings. Of course, previously we have tried all the dry millings, but impossible to get the nano size. Because if you use dry millings, you mill it for certain times, I think all the particles themselves, I think it will be accumulated. So the minimum micron size we can obtain about 10 to 20 micron size only if you use dry method. But if you use wet millings, But here, if you want to produce water-based, you have to use all the distilled waters or other water-based material to mill. If you design for solvent-based, you have to use all the solvent-based material like maybe some alcohol. Yeah, it depends on the material itself. So here we just use a planetary ball mill machine with zirconia jar 400 RPM revolution per minute for 8 hours. Then we can obtain this nano acyl biofuels. But here we use the TN to measure the mean nanoparticles mean size is about 30 to 40 nanoparticle size. But this is just a small scale. If we want to upscale it, this nano acyl biofuel, we have to use the liquid mills instead of this planetary ball mills. Because the planetary ball mills, the jar is the capacity is very small. Maybe maximum we can do only a few hundred grain. So of course we are trying to upscale all these nano acyl biofuels for industrial applications. So this one I will share in the next few slides. So of course we have many technique or measurement to characterize or investigate these induction coatings, all the properties and performance. So we can try using this Bunsen burner test, SEM or FESEM, static emission test, Freeto cycle test, adhesion strength test, toxicity, corrosion test, fire propagation test in accordance to all these pretty standard 476 passes, surface spread of frame test, pretty standard 476 part 7, cone calorimeter test, ISO 5660 part 1 standard, TGA, FTIR, DSC, limiting oxygen index, UL94, whether you conduct it vertically or horizontally. So fire resistant test for building materials in accordance with this PS 476 part 20. I think the last one, yeah, we are targeting this test with industry partners in the near futures. Fire resisting duct, pretty standard 476 part 24. So this is a very stringent test, yeah, if we want to fulfill. So for this slide here, I just share with all of you the number 1 to 5 only Bunsen burner test until this adhesion strength test. Actually, we have conducted all the tests except the number 16, the fire resisting duct. We haven't conducted this test. So this is a Bunsen burner test. Yeah, if you can see on the left side, this is very simple setup for this fire protection performance test. Yeah, we just use this digital thermometer. Yeah, I test with this steel plate, then we burn it for 60 minutes. Then you can see all the equilibrium temperature of this induction coating samples. So the performance indicates that the equilibrium temperatures of this coating ore was significantly lower than the other coatings. Yeah, so it presented the best fire protection result for the coated steel plate with induction coatings ore, and the equilibrium temperature was nearly 182 degrees Celsius. So an appropriate combination of frame return fillers with the addition of this 4.5% of these nano acyl biofuels with polymer binders and frame return additives had led to constructive results by forming the thicker char layers. But here the thicker char layer is 35.5 mm. So it expands about 15 times as compared to original thinners. So here's to ensure the formation of a uniform and dense form structure. So this indicates that physical and chemical exchange has occurred, so resulting in excellent fire resistance of the char as well as the adhesion to the steel plate. That's why we conduct this test vertically, so we can see whether the char layer will fall off or not. We're exposed to 60 minutes fire test. So next is SEM. So the image of coating element illustrated the largest holes and voids. So the tiny holes and void structure could be the consequence of fire and heat propagation. So the fire and heat propagated the break of other cells on the foam structures could lead to a very poor fire protective performance of the coatings. So on the other hand, the char layers of coatings N and O have displayed a more uniform and denser foam structure, which could segregate the steel substrate from the fire due to the addition of acyl nanobiofuel. So next is the adhesion strength test. This one also designed by ourselves. Yeah, if you follow the industry, normally they use the dolly sample to conduct this test. But here, because our university have all the instrument machines, then we just modify and design this steel rod. So apply all the sample on this steel rod. Yeah, then we just put it off Then from here, we use these equations. Adhesion strength equal to this maximum log at ruptures divided by this adhesion area. Then we can obtain this adhesion strength of each samples. So based on these outcomes, sample O with the addition of 4 by 5% nano SLs fillers, the adhesion strength here can achieve 2.87 megapascal. So the increase of this adhesion strength of coating N and O could be contributed with the addition of this nano SL biofiller by providing better reinforcement properties. In addition, the larger surface area of the frame nano fillers have further improved the bonding interaction between the coatings and the substrate as well as between themselves. So however, the formation of void in the matrix of coating M and O attributed to the loss of adhesions between the coatings and the substrate due to the mechanical stress occurs. So next is the free-toe cycle test. So all of the coated samples are still remain unchanged. Okay, so we conduct this one for 21 free-toe cycle tests. So all coating samples have proven to be efficient to withstand the highly destructive forces of cycling, freezing, and towing. Only the coatings, maybe the sample L and O, without the addition of these nanoparticles fillers, so the surface is not smooth. Yeah, you can see the porosity of the surface of this coating. So next is the static emission test, actually to determine the water resistance of these coatings. But for your information, this type of fire coatings is for indoor application or in internet application, not outdoor. If outdoor, then we have to consider all the rains, all the sunlight. So this coating samples all has comparatively shown the least changes of weight percentage throughout the test as compared with other samples. So this is because of this 4.5 weight percent this nano SL biofiller to the front ingredients and this ring acetate copolymer riders that could slow down the permeation of water and migration of these front materials due to its enhancement in resisting the water permeation. So the conclusions, in conclusions of this 4.5 weight percent of renewable SL nanofillers in the coating formulations indicated a significant improvement in terms of charge formations of the coatings, water resistant, free-toe cycle resistant, and adhesion strength of the intimation coatings. So the selections of an appropriate combination of frame-related ingredients of the coating lead to positive results on the fire protection, physical and mechanical properties in protecting the substrate. So significantly, frame-related nano-sized SL biofiller is one of the dominant biodegradables and sustainable nanomaterials found in nature, as well as its potential role in various fields of engineering applications towards sustainable development goals in the future. So this application, this intimation coatings has been applied in oil and gas industry, automotive industry, but in Malaysia, we won't see any car apply this fire coatings in front of maybe the car structure or the car engine structure. But Europe side, they have applied this, in case of fires, so it can prevent the fires, maybe all the heat penetrate into the passengers or drivers. So these are extra fire safety protection for the drivers. So this intimation coating also has been applied in industry factories, high-rise building, airports, and shopping mall. For the high-rise building, normally they apply in all this air conditioning ductwork system. As I mentioned just now, the PS476 Part 24. Normally they focus on this air conditioning ductwork system. So this is the production process of this intimation paints. Very simple step. So here we just collect all the SLs, waste SLs, then you dry it to powder forms, then wet buildings. But here we use all the paste. We are not going to try this all the paste. So we just after we mix, then we just mix with all the binders and all the frame ingredients. Then we mix it until homogeneous. Then it can be applied. On all any substrate. Maybe I will show you this. I think it's 1 minute video. With fire coatings and without. So actually, this test indicated that these indumation proteins can maintain the integrity of the plywood when exposed to 20 minutes 5 years, 20 minutes only. So we just apply about 1 mm of this indumation coatings, so you can see the difference on the left and right side. Yeah, on the right side, I think fully burnt without this indumation coatings. So with this indumation coatings, it can help to protect the substrate when exposed to 5 years. So next is the applications that have been applied in my university. This one previous I conduct this experimental works under this PRGS. Yeah, so we apply our materials, our innovations, or paints on this air conditioning tap. I think beside the biomedical engineering buildings. Yeah, this one already I think 7 years. We applied this in 2014. So after 7 years, we can see this material still look like original. So we can prove that this material is can be applied for on all this air conditioning ductwork system. So these are our milestones. Yeah, this is our milestone. You can see from step 1 to 8 So now we need to start to have this fundraising for upscaling to conduct all the international standard fire tests, as mentioned just now, the number 16, the PS476 Part 24, full patent applications will be applied if the test can pass the standard. So yeah, this is the slide I would like to share. Yeah, so we will have this research collaborations with this TSYL Visions Sendirian Berhas. So actually, this is the information from the fire safety department or bomba fire resisting duct. So here actually I mark the 3 performance here are the criteria for all these fire resisting duct. We have to fulfill the stabilities, integrities, and insulations. But here you can see there are 4 most common fire rated duct in local markets. So here's actually if you use this indumation coatings, it only can pass the integrity. So what about the insulations? So that's why we need to investigate further how to pass these insulations by maybe incorporating with all the some materials to fulfill these insulations criteria. Yeah, so this is the next challenge we would like to achieve. Yeah, to break through. So this is the founding teams from all my research members. Yeah, some from industry. Yeah, the IR Hong is my mentor. Yeah, he has more than 30 years experience in industry. So his advice and experience is very useful. Yeah, to give all the directions how to apply all these research materials. Yeah, to benefit our societies and maybe the countries. Yeah. So that's all. I think my presentations. Yeah. So of course, by presenting this research, it may take 20 minutes. But in real life, if you want to study this research, it may take a few years or 1,000 days to study or investigate all this fire protection performance. So sometimes, as a researcher, we have to remind ourselves, as long as okay, there is a view so there is a way. So we always try our best to achieve all this research towards commercialization path. Yeah, I think that's all my sharings for these sessions. Thank you.
Okay, thank you, Dr. Yu. Thank you for the fruitful sharing.
Thank you.
Yeah, right. Okay, ladies and gentlemen, now we come to the Q&A session. Yeah, I think Dr. Madam Noor Ain would like to ask question here.
Yeah, I'm Noor Ain from UM. Thank you, Dr. Yu, for your presentation. So I have one question. May I know what is the best technique to dissolve your nano shell into the coating matrix? You know?
how to mill? You mean how to mill the eggshells in
Disperse,
the
yeah, the eggshell, the nano eggshell, right? What is the best way to disperse it into the coating matrix?
Yeah, as I mentioned just now, after we mill with all the, if we design for water-based, then we will use all the water-based solvents, like distilled water. If we want to design for water-based, then after we mill, then we just use all the SL powder, not we call the SL paste, then mix with all the ingredients. Yeah, we cannot let it dry. So this is the method we can maintain the quality of this nano SLs incorporate into all these flame retardant additives. Yeah, we cannot let it dry. Yeah, because in industry, paint industry, normally for some like pigments, yeah, industry people, if you go to all the hardware shop, like if you want to change the color of the paint, so nowadays most of the hardware shop they just uh, add in some pigments, right? Yeah, if you want to have all the very light colors like green or blue, they just dose it a little bit. So this is the method, yeah, we can apply. Yeah, paste, yeah.
Thank you, Dr.
All
Yu.
right.
Okay.
Okay. Thank you, Madam Ain, for the question, and Dr. Yu for the answering the question. So next question is from the Q&A box. So this question from Dr. Juan Jun Cheng. So he said, "Hi, interesting topic. What is the size of the eggshell that you have milled until become nano size? And then secondly, solvent and time required to mill until nano size. Thank you." Yeah.
Yeah, this one I think previous slide has been shared here. Actually, it takes some time to mill. Yeah, as from this slide, we took about 8 hours. Yeah, under this 400 RPMs. Yeah, you can see 8 hours to obtain this nano axial biofuels. But of course, yes, we have to play around with other methods. Yeah, means the planetary spore mill itself. Some you can set to reverse direction. So this one we have to set. But here we didn't show all the details. Yeah, we didn't show the details. You have to play with the planetary ball mills. I think the best one is to use the electric mills, as mentioned here, upscale the nano SL. Because this one the speeds can speed out to 2,800 RPM. But for this planetary ball mills, normally it's just a few hundred RPMs. Yeah. So the best one is to use this electric mills. But here's the ball mill, all the size are different. Yeah. You have to have to measure all the ratios. That's why, as I mentioned just now, we tested many times, a few hundred times, only can obtain this one. Yeah, so we prove this one. This is the nano size we can obtain. So maybe many industry have asked us, because this invention has been participated in many competitions or exhibitions. Many industry people they ask, if I want to produce this SL and nano SL, do you think this is practical? So my question here, yes, because for this introduction coatings, as you can see the formulations, normally we can incorporate the maximums only up to maybe 15% of these fillers. So if you can produce, let's say, 1 metric tons, so actually this introduction paints we can produce up to 10 metric tons. We just need about 10% of this SL powders. So actually is applicable for industrial application. That's why when we explain all this to industry players, so they are interested to work together, yeah, with us. So we hope this thing can be commercialized in the near future.
All right. Okay. Thank you, Dr. Yu, and thank you, Dr. Juan, for the questions. I think this is the last question, I think, from Dr. Malinda. Interesting share, Dr. Yu. What is the challenge that your team is facing during the processing of intermittent coating?
Okay, actually the challenges we face is the raw materials. Yeah, so as we know, this friendly additive, in Malaysia, we actually cannot get all these raw materials. So we have to rely on some other countries. Yeah, that's why you can see industry, all the factory in Malaysia do not provide or produce this kind of fire uh, protective pens at the moment. That's the reason. So, like, maybe I can share some things about industry lah. So far, only the wind ducts and wind ducts have these materials, but they or they collaborate with Austria. So actually, all the Indonesian products actually imported from Austria lah. But of course, these companies have all the collaborations with them lah. So that's why, as I mentioned in the open statements, this kind of fire protective coatings is very expensive because only a few industries have these products. So actually demand more than supply. That's why there's a reason here why this kind of fire resistive paint is so expensive. So if we can produce this one by using all the waste materials without compromising on the quality of these illumination paints, of course we can produce this illumination coatings ourselves, in Malaysia. We don't need to rely on other country. Yeah.
Okay, Dr. Yu. All right. Thank you very much, Dr. Yu, for the insightful sharing. So, right. So we almost end our session for today for biomaterial and polymers session. So now we reach at the end. Thank you for the participation. So on behalf, right before we end, I forgot the announcement about the session best presenter. Yeah. Okay. Right. So since we only have for today only two presenter or a presenter, right? So I would like to. I'm very honored to announce that best presenter for this session, biomaterials and polymer session, goes to Cik Noor Ain Muhammad Razali. So congratulations to you as a best presenter. Right. Well done. Right. Okay. Right. You should share this with your lecturer, yeah, Dr. Nur Shahida, yeah. Right.
Okay, insyaAllah.
Congratulations. All right. There is a congratulation notes there. Okay. All right. Ending of the session. Yeah. We are reaching the end of this session. Thank you very much to the presenters and also the inviting speakers, right? Joining us in MICNC 2021. I would like to seek for your kind of cooperation to fill up the feedback form that has been given by our moderator in the chat box. Okay, you are also invited to join the rest of the event. I'm sure there's another section still going on here, right? So I'm also you can also go to the networking session as you can see from the program tentative. I hope to see you again and thank you very much for your participation. Okay, see you. All right. Thank you.
Thank you, Dr.
Thank
Nora.
you.
Thank you.
Oh, hello. Oh, I'm talking, but I forgot to unmute. All right. Okay. All right. Just
Yeah.
a quick one. I'm going to share tomorrow. I'm going to have a presentation. So I like to share my slide because
Yes.
last time Sabila sharing the way to sharing the slide, right, without closing. Then she was mentioning something as well recently. So I like to open my slide and share with you. So that, yeah. Okay, thank you very much.
Yeah, sure, doctor.
What is it here? Presentation. Let me because my presentation will be in the morning, so I think it's time for me to try it. Okay, so now I already opened my slide. What's that? Okay, I open back. All right. What should I do for the slide? Slide sharing first. Okay, all right. So Windows. Try to win the Windows. Okay. Okay. Can you see? Right. Can you see my slide now?
No, I can see your
Cannot?
screen,
Cannot or not?
doctor.
I cannot hear you. Cannot.
Cannot.
Oh,
I can see only
my
your
screen
screen.
only.
Yes.
So I think the same like
Yes.
the lady just now, right? So so I cannot make it as a sharing. Maybe again I will try share Windows.
Yeah. Try,
Hmm.
try. You try, doctor, to open it and then make it as the
Oh, reading
reading
mode.
mode, something like that.
Reading mode. Okay, okay, like that. I open it. I already open as reading mode now. Okay, now can you see? Okay, how is it
Yes.
now?
Now, okay.
Now, okay.
Yes.
Okay.
Yes.
So I have to go as a reading mode.
Yes.
Okay, okay.
So now you can see the open as well, right?
Yes, yes, yes. Good,
Okay.
good.
Okay.
So let me see how. Okay. So, okay. I can see the open and also I can see my reading mode. So let me try to scroll it. I mean, to go to another slide. Okay, good. So reading mode.
Okay.
Reading mode. So it's already shared in the, I mean, slide individually, and then now I just go to the reading mode lah. Yeah.
Yes. Yes.
Okay. Right. Thank you very much. That's it
Mm,
from me. I
welcome,
mean,
doctor.
my voice is okay. Now we're using this headphone as
Yeah.
well.
Yeah. It's very clear.
Right. Good. Good. Okay. I hope. Right. Until the end. Just, just a quick one. Okay. All right. So ended. Okay. Thank you very much for your
Okay. Welcome.
for your very kind help for
No.
everything.
No.
All
It's
right.
okay. It's okay, doctor.
Okay. Okay. Maybe we
Okay.
can go to another section. Thank you very much.
Okay. Sure.
Bye.
Sure, doctor. Bye.